Hi students, good morning all of you. Today we are going to discuss system of particles and rotational motion. In this chapter, this is the first lecture. Before going to this chapter, we will discuss the basic information. Okay? Right now here. First, rigid body. Rigid body. An ideal rigid body. An ideal rigid body. An ideal rigid body. An ideal rigid body whose shape and size can never be changed. Whose shape and size, whose shape and size can never be changed. Can never be changed. Whatever may be external influence acts on the body. External force acts on the body. So the body shape and size can never be changed. Okay, this rigid body may have rigid body may have translatory motion, or rotatory motion, or rolling motion, Okay, students. So this is rigid body may have the translatory motion or rotatory motion and or rolling motion. So first of all, we are going to discuss what is the meaning of the translatory motion and rotatory motion and rolling motion. Let's know is here. What is the translatory motion is? What is the translatory motion? At any instant of time, remember here, translatory motion. Okay, students, translatory motion. What is translatory? At any instant of time, all particles of the body moves in the same speed. Okay, all particles of the body have same speed. All particles of the body at any instant of time have the same speed. So all particles of the body at any instant of time, all the particles of the body have same speed, or all particles of the body have the same displacement in the same time. It's called the translatory motion. So when you observe here one of the example, let's know is here. This is smooth surface. This is one of the body. All particles of the body moves. At any instant of time, all particles of the body have the same velocity. Okay. This is one of the translatory motion example. So once again I repeat this. All particles of the body at any instant of time have the same velocity or same displacement or in the same time is called the translatory motion. Right now here. So another example we are going to discuss is here. So when you take the inclined surface, this is one of the inclined surface, one of the object is here, moves in downward direction. This is one of the object is here. So P1 particle, another particle P2, and with the number of particles have in this body. So when the body moves, all particles have in the body same velocity, same displacement at the same time. This is called the translatory motion. Okay, students. Next, what is about the rotatory motion? Good. What about the rotatory motion? Right now here all of you. rotatory motion. Rotatory motion. Listen all of you. What is the meaning of the rotatory motion? The motion. The body moves about an axis. The body moves about an axis. The body moves about an axis without change its position. Without change its position. Without change its position is called rotatory motion. So observe carefully all of you. The body moves about an axis without change its position is called the rotatory motion. One of the best example is observed carefully. So this is the moving. This is a moving at the top. You observe here. This is what the top is here. About an axis. About this is one of the axis is here. The body. This body moves about an axis. The body moves about an axis without change its position. Without change its position. This is called the rotatory motion. And moving the ceiling fan, one of the best example. Moving the ceiling fan and moving the top. This is one of the best examples about this the rotatory motion. Okay, students. Let's know is about the rolling motion. So you observe. First of all, we discussed now here translatory motion and rotatory motion. So here. So another example. This is rotatory motion example. Moving the ceiling fan. And moving here this top of the board. Next, what is a rolling motion is there? Rolling motion. If a body possesses rolling motion, this is very important concept. Rolling motion. Rolling motion. What is a rolling motion is there? If a body possesses both translatory motion and translatory motion and rotatory motion. So if a body possesses both translatory motion and rotatory motion. Translatory motion and rotatory motion. Then it is called the rolling motion. Okay, students. So the body possesses both motions are not translatory motions and rotatory motions. For example, you observe here. So here, last class we already discussed is here. This is ball. Very small ball. The ball is rolling on the smooth surface. You observe here. You observe that this ball is rolling. So here, as students, observe here. The ball is moves along a straight line and rotation. So translatory motion. This ball have a translatory motion and rotatory motion. Translatory motion and rotatory motion. Moving ball. So here, this is a rolling motion. This is one of the best example about the rolling motion. Right now here, in the rolling motion, both motions is here translatory motion and rotatory motion. In translatory motion, the body, all particles of the body, same linear velocity and linear displacement. Same linear velocity and linear displacement. In rotatory motion, all particles of the body different moves in different circle. All particles of the body moves in a different circle. Okay, so in different circles, so in all circles, center of the all circles lies on one line, that is called the axis of rotation. Good students. So for example, all particles, this is a different particles, this body have a different particles. Observe carefully, these particles have a different, this body have a different particles. Okay, all particles have a different circular path, different circular path. All circles lies along a same line. All center of circles lies along a same line. That line is called a, what is that here? Axis of rotation. This line is called, what is that here? Axis of rotation. In rotatory motion, angular displacement and angular velocity are the same. Angular displacement and angular velocity are the same. Right now here. Next, this is a basic information. Let's know we are going to do the center of mass. Listen all students. What is the center of mass of the body? So, what is the center of mass? Listen here. Center of mass. Center of mass. The center of mass of the body is a point. The center of mass of the body is one of the point. All body, total mass of the body concentrate at that point. Total mass of the body. All total mass of the body concentrated point, that point is called the center of mass. Okay, total mass of the body concentrate at that one point, that point is called the center of mass. Okay students, let's know one of the example is here. For example, when you observe here, one of the wheel is here. Take one of these what is that? Disc. When the disc is moves along a straight line, along the straight path. When the disc is moves along the straight path. So when observe here, we take here the different particles at the end of the point A and B and C. C point is the center of this body. Okay, the different particles is here. When the body moves, when the body is rolling, that is rolling is when the body which have both motions. What is that? Translatory motion and rotatory motion. This disc or ball is moving in a straight line. That is a translatory motion. Okay, students. And the rotatory with angular velocity omega. Both velocities. Both type of the motions have this in the body, that is a rolling motion. When the body is rolling, observe carefully. A particle, for example, this body is reached here in this condition. So this A and B point places also is a change. So here A point comes to this place, A, B point here and C point here. Another time this body is rotate and moves in the straight line directions, moves here to the straight line, moving in the straight line. So this body's positions also is a change. So this is the A point and B points also will change. C is a constant here and A, this point and B. When you observe here, A and B point, when you observe, this A and B point follow the, what is that here? Path is here different. Different path. So when this path is like that here. Different positions. Follow this a different way. So when observed in the C point moves along a rectilinear motion. Linear translatory motion. This is never changed. So this is called the center of mass of the disc. The center of mass of this body is path is never changed, moves along a linear motion. Okay students, that's why we take the center of mass of this. What is C is what is that here the center of mass of the body. Okay students, this is the basic information about the system of particles of rotational motion. Next class we will discuss about the another important points. Okay students, okay, bye.